now I distribute that maybe over a cluster of CPUs instead of a big honking power hungry GPU.
Yeah, no, see, we definitely see a hybrid future, and it's going to be more towards efficiency, right? I think that's the key thing that we should look off because we have like 6 billion plus people, right? And like today we don't have the GPUs or compute or CPUs to like serve AI for all of them. And if we want to get to that number, CPUs are going to be a big part.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On this episode, AI at the Edge, securing, scaling, and streamlining data workflows with Nilesh Agarwar, co-founder and CTO of InfraLess. Nilesh, welcome to the show.
Hi, great to be here.
Hey, I'm really interested in our topic today because there's a lot to do around the whole data management, the whole data at the edge, and AI and how that has a big play. But before we drop into that, because that's exciting, I'm going to get all worked up. So I'll forget to ask. But Nilesh, on my show, I don't know if you know this, but I only have superheroes on my show, and
Thank you
every
so much.
superhero has a background story or an origin story. So what's your origin story?
Yeah, no, I think just a little bit about myself. I'm Nilesh. I'm the co-founder and CTO at InfraLess. And before this, I've worked a decade or more in machine learning and infrastructure. Started with a US-based company. They used to provide CI/CD as for banks. Worked there for 3.5 years. Published a couple of patents on how to predict like code defects without them actually happening. Then spent a couple of years at Amazon in the machine learning team where we were trying to predict what kind of ad sets should be published. So this was the era of like classical regression-based machine learning, still processing like terabytes of data, but very different than the machine learning how it works today. So was involved with machine learning back since 2017. Saw the evolution from regression to LLMs to now diffusion and like every aspect of our life being affected by machine learning. So also
So
did
you've seen
another
the
company.
gamut. You were there. Well, you weren't back in the 1950s when they first talked about it, but you've been there for the last what 10, 15, 20 years, right? Watching the progression of AI. You've seen a huge jump in just the last 2.5 years, right? I mean, massive jump.
Yeah, I think when we started, it was like mostly like experimental, but now it being in every aspect of our life. And yesterday, Google like just made it part of your everyday suite, where now like even like talking, searching, it's all AI. Everything is just like tokens being passed to us as compute. Yeah, it's pretty interesting time to be in.
Yeah, it is. Well, and everyone's enamored right now with Chat GPT or GPTs in general, right? But there's so much more. That's just a small amount, and I think there's been a lot more money dumped into AI projects that have been wanting money dumped into them for a long time, and now we're seeing progress in the whole industry instead. So I mean, in a lot of respects, uh, OpenAI has really kind of unleashed a lot of money across several different companies because of what they've done. So this is all good news for us, right?
Yeah, yeah, it's good to be in the AI space, and now it's like finally rewarding.
Yeah. So, but there's a big problem that no one wants to talk about AI, and it's about data. And that's where you guys come in, right? I mean, you
Yep.
guys, you've got some strategies around data. What issues do you run into typically with data and AI?
Yeah, so I think again, as we moved into this era of AI, right, building systems around data has now been more important than just like traditionally compute. Traditionally, it was like wherever we have the best compute, whoever has the best compute wins. But now the focus has shifted on data, and it's affecting all stages of pipeline, starting from training, right? How do you get the right set of data? How do you get data efficiency now? So you can have the same data like multiple of times and train the model, and it will not work. So now the new term that has come in data is like how efficient data is for training, right? Is the data set varied enough? Does it have like different things? and it's super hard to do so, right? With like especially the PII and the like not having like them give you direct information, but having it masked enough, but then also like having the core insight safe, right? So around data security, it has been huge in terms of like building pipelines for how to get the training data, removing data, your personal data information. So that has been the first part. Second has been more around like doing inference at scale, right? When you're talking about like millions of API requests per second, how do you scale from one machine to like thousands of machines, especially for consumer applications, right? Most of the enterprises are like trying to ship products which general people can use, and for that, like scaling machine learning has been like a big problem, especially with like bigger. So the model weights now are in like hundreds of gigabytes, so 100 gigabytes to even a terabyte for some uh, billion parameter models. So that has been like really hard and challenging. Yeah.
Yeah, so it sounds like AI has just created a bigger data problem or exposed a problem that's been there for a long time. Like you mentioned, security, cleaning, all this stuff. So, do you see have you seen organizations starting to be concerned about their data pipelines and data management in general, or are they still kind of oblivious to it? What are you seeing out there?
So I think definitely, I think most of the enterprises now see, right, have started like doing this like data warehouse approach where they are more strategic about how the data is, how do they expose these data to the models. So we see that as a growing concern, especially in enterprises who want to like train these custom models with, let's say, uh, thousands or billions of chat which they have of their customers, right? How can they ingest them but not expose like critical customer information? And this has been the reason why most of them have been moving slowly, right? Because they want to be cautious. They don't want to be come into a place where model has exposed, let's say, your email or your phone number, or even so bad like your SSN, which they are like all in the system for banks and bigger enterprises. So that has been, I think, there are different strategies that organizations have been doing. Some have been like fairly conservative when they don't expose that, and then they are trying to build systems of data which can using RAG or using a like moderated data pipeline which can give access to these models to these systems. Yeah.
So that's really interesting. So we're starting to see some changes here. But you mentioned data warehouse.
Yep.
So I always had a problem with data warehouses because you've got to go find all your data first and then bring it under one central control. That's just not reality,
Yep.
right? Especially when we're talking about petabytes of data, and moving petabytes of data around is time consuming and cost prohibitive a lot of times, especially if your data is scattered in multiple clouds. So it's almost like we haven't really bridged how to fix this problem. We're just putting band-aids on it. We're using brute force methods like a data warehouse to handle this. Are there any options out there? I mean, for this?
So yeah, I think there are a lot of. So I think yeah, still it's the problem is still out and open. It's still not been solved. There have been solutions, but the adoption of those solutions are like seriously in like high question mark. Because everyone says that yeah, you buy our software and we can convert it everything into a single tabular structure. But just understanding the complexity of like what are the different table, what is the relationship schema between like all of the data which is in your warehouse is super hard. We are now seeing actually breakthroughs in like LLM where people are now deploying AI to understand the data. So again, that's both risky and like new. Because I think from a solution point, it's like so personal to an organization. Like there's no repeating pattern which you can build a single product and sell it to like 10 enterprises, right? It's very different for each enterprise. So I think that is the biggest foundation that has stopped like a solution which can like just homogeneously solve this heterogeneous problem.
So there's no silver bullet. So it must be really good. I mean, this looks like an area where if I'm starting my career, I should be strongly looking at, right? Because this is an area that AI can't completely help us here yet, right? You need
Yep,
humans in the loop there to help figure out what the data is and how it's all related to each other. Very complex problem.
yep.
So, all right. So, are there any other options besides the data warehouse that we should be looking at as far as data architectures, or can I start doing some of my analytics kind of out at the edge instead of just pushing things into a big, huge data center?
Yeah, I think definitely. I think now there are all of these databases, which are newer databases that have come out, which are like RAG-based databases, which are retrieval-based augmentation. So we see this as the most deployed technology in the bigger enterprises, where they're trying to see that, hey, how can we build an API layer where we can dump uh, the data you want to query quickly, but not in a form of a traditional SQL or a NoSQL, but more in form of like vector databases where the LLM does the job of like actually finding the right answer for you, and then it can look across various schemas, various datas, right? So we see a lot of these augmentation, real-time data augmentation platforms come up. NVIDIA has launched their enterprise suite where you can deploy it in your own VPC, and then it will just find the data for you and get it for you. Yeah. So I think we are seeing a lot of like big tech also do a lot of innovations in this.
All right. So, where do you see the future moving forward then? If we're kind of at this crossroads with data, right? I can process some of my data where it's at, but most of, and you mentioned the models are getting very large, even the metadata on these models are approaching terabytes. Where do you see the future? How do I plan for the future? What do I do?
Yeah, so I think definitely, I think for all organizations, it's like super important now to have like some form of AI like within them to also find data. AI has also been a great enabler of like data access. So now you can ask very complicated queries in like supernatural language to get that processed. So I think a good starting point for most of the companies would be to figure out solutions that first create the essential data pipeline of just like getting the PII and like sensitive data out of the data warehouse and then have it like in a separate place. So that's, I think, the first starting point. After that, of course, there are like a lot of solutions that you can use to get a RAG database and then like start pushing some form of AI either in-house or like a managed endpoint uh, to get those in. So I think the first data is definitely getting your data security right, and that's again like like that's something that each like organization has to grunt out and find it for themselves. But after they have that, getting data access now like to people across the organization, that is something that AI can do really well. And then it's just from that point scaling data like queries.
So you mentioned security and PII a couple times. That are there more and more regulations that are preventing data being used in public Gen AIs because of the potential problem of data leakage? Are you seeing that as an issue, or because you work primarily in highly regulated industries, correct? Like banking
So
or
yeah, so we
healthcare?
have customers in healthcare and like not many so in banking, but yeah, like the general access is like what we have seen is right. Like so, there are models now also, right? Because of hallucination that they spit out. Let's say you ask a question and they spit out someone's email and someone's like PII data. That has been the first wing, and we work with this really good startup called Clean Labs. They are trying to like do LLM based data cleaning, so they understand your data and you can just throw them a like a big set of data, and then they use like LLMs to clean that data. So now AI is also helping us on the former part.
To clean it?
And
Oh, that's interesting.
yeah, so it's a interesting startup, and they are trying to like build the first layer which you talked about more, and then they use us for like powering those LLMs. So like they also need a lot of compute to like clean the data, to understand the data, and then create it in a format where it's safe for further use, right? So we see some LLMs, but again, these are like LLMs which required very high security. It should be like not connected to the internet, because when you're asking LLM to do the job of cleaning, right, you can't really have that LLM leak the data outside, right? So there are like offline and online systems, and then offline systems are like working in a closed box in a machine with probably no internet, and then they're trying to do this cleaning task. where you get the data. And then there are second part of systems which are online, which are meant for retrieval and indexing, right? Uh,
So
so
that's
uh,
a, I want to touch on that point a little bit because I don't think my audience fully understands. There are private or offline LLMs that you can use that will not broadcast your data anywhere else. They're staying there. These private LLMs are, a lot of them are open source models, are free that you can download. No fear in those sending data back anywhere. Those are locked down. But the public Gen AIs out there, like ChatGPT or Claude or Gemini and thing, or even Copilot, these are public Gen AIs, right?
Yep. So I think, yeah, so I think this is a very interesting space where we are seeing like two parts, especially like for the PII and data cleaning, right? So there are a lot of setups that are done in with like on-prem GPUs where they are like systems which are cut off from internet, and then they are responsible for cleaning all the data and doing the data preparation. Now they are smart by themselves. They are using LLMs, probably like DeepSeek, Llama 4. We see all of these kind, and then a lot of encoder decoder models. Using these to basically just strip out all the PII, and then they can be very smart about like doing the cleanup. And when you are doing this setup, right, you want like it to be completely sandbox from the external environment. So in no way the LLM can shoot out your like data outside. Once it's done, then the data is disconnected from the LLM, and then it's plugged into a system which is like more online, something like a Chat GPT or a Claude, where now the data which is there, it's like fully clean, right? It does not have any personal information. And then using this for like online processing is super safe. And then we have like a layer on top of that, which we also power and help, which is hallucination detection. So what we can do is we are having guardrails in the online that even so, let's say we try to do a job and right, it's 99% done, but still there is some data which got leaked, right? So then there are like guardrails which are on the last step of these open models, which prevent them from data extraction, right? So there are these hallucination detection. There is guardrails for any PII data comes in, it will block the request. So there are three layers of security, which we see most companies do. So one is like offline cleaning. Then there is online systems which are also having like hallucination detection and like risk detection for like throwing out any data.
I'm glad you brought this up because a lot of people think, oh, I just buy an LLM or I just get Copilot and I'm ready to go. What you're talking about here is the integration of multiple models together to get something done in a highly secure manner. I think this is a whole new branch of computer science that we've never seen before, because now we have a natural language processor that we can now program and interact with, and people are calling these agentic AI pipelines or data pipelines. We're going to see more and more of this sort of stuff in the future, right?
Yeah, definitely. I think in AI, the biggest thing is about the pipeline. So I think the kind of like handling data is just not like at one end that you just like have a compute server and then you give it access to a database. So that was the software
That's the old way.
yeah, that's the software 1.0, but now with these like advanced processor, because there's more risk now, because in natural language, if you ask it something, you might
It
not
will
want to
tell you.
answer that. It will tell you, yeah. Yeah, so you might not want to do that. But then again, you want like it to be intelligent enough so that it can do some things which you are allowed. So to federate this data, you need multiple steps of data. You need staging, you need like cleaning, you need like access, and then you need something on the top which is more of a super active like guardrails. So there are LLMs which are just specific for guardrails, right? So their job is to only evaluate that the prompt which has come out, is it safe for me to like pass it on to the user, or should I like strip out data and then pass it to the users? So the
It,
last layer is also something that guardrails LLM is also something that in the last year we have seen a lot of research and a lot of good companies come in that also.
yeah, I was going to say. I mean, if it weren't for people trying to jailbreak ChatGPT and get it to do things it's not supposed to do, there wouldn't be so much research in guardrails and both in prompt input and output.
Yep.
Great stuff. So, Nilesh, if we look at the ability to do some of this work, because you're talking about both private and public models being used to do this sort of work. Do you see hybrid and heterogeneous workloads the wave of the future, where I've got models running everywhere now and doing and the whole idea is to push data around and to get some value out of data? Is that the future? And then how do you manage that? I mean,
Yep.
it's got to be a nightmare to manage.
Yep, yep. No, that's definitely, I think you're on the right lines that like the AI pipeline is much more like complex, especially because like even with Chat GPT 4.0 and like even with their 5 model, right? So now it's not just one model which you have to manage. There is a graph of different models. So one model probably does the detection that, hey, should this query be answered by a small model, big model? Then the second model says, okay, do I need to output an image out of this query, or do I need to output
Oh,
a Excel sheet?
yeah. I'm glad you brought that up because people think that ChatGPT 4 is just massive, huge, big model. No, it's dozens of models interacting with each other, right?
Yeah, so now we are evolving into this graph kind of a pipeline where there are like smaller task specific models, and then there are like bigger models which just do one part of the job, probably creating image, and these are all integrated as a part of a single AI system, and then they produce an output, final output. So the final output might in the path have gone through like 3 or 4 models. Even the Llama 4, which just got released a week back, they are a mixture of like 16 experts. So there are 16 different models trying to evaluate the query and trying to answer it. And the activation path of them is something that's like completely depends upon what you ask it.
So just as we thought things are going to be easier, they've become more complex.
Yes, from an infrastructure point, I think the biggest bottleneck for I think AI to scale is right the compute it needs, and it also needs to be efficient compute. You can't just throw like 1,000 GPUs for processing one query, right? That doesn't work in real world. You have to figure out that, hey, is this a task of like uh, high intelligence, or is this a task of high classification which I can done get done by a small like model? So there is evaluation on what kind of task it is, and then there is like another whole pipeline that comes in. Okay, now this is this type of task, and then you can be wrong about that also, right? So there's a pipeline that also flows back that, okay, I was wrong, then let's restart this whole process. So especially with DeepSeek, right? The reason why DeepSeek surpassed ChatGPT and most of the benchmarks when they released was because of this technology called reinforcement learning. So it was trying
Right.
to answer it and then trying to relearn from it, answer that, hey, did I make a good job at giving this answer? So this makes the AI pipeline super more complex, right? So now it's a model that also thinking and then trying to do the task again, right? So RL and like is becoming the future of how like all inferences will be done. What we bet is because it just reasoning like and like you can reason fast with compute. So the Jensen even keynote, I was there, and what he said that like to answer a single question, right? If in 2024 it took like 1,000 tokens, now it's gonna be like 15,000 tokens. So now you can understand the scale of compute we need to like manage this.
Well, and there's a huge problem if we think that all the models have to run on GPUs, which we know they don't,
Yep.
especially these smaller embedding models. So do you see in the future that I'm going to be using a lot more smaller models instead of these big Goliaths to get answers? And can now I distribute that maybe over a cluster of CPUs instead of a big honking power hungry GPU?
Yeah, no, see, we definitely see a hybrid future, and it's going to be more towards efficiency, right? I think that's the key thing that we should look off because we have like 6 billion plus people, right? And like today, we don't have the GPUs or compute or CPUs to like serve AI for all of them. And if we want to get to that number, CPUs are going to be a big part. Like CPUs are really good at encoding, decoding, right? They can do that fast. They can do that so we see a future where it will not be just GPUs. It will be probably GPUs working alongside the fleet of like CPUs and working basically all of the compute working together to get the most efficient pipeline, right? So there will be smaller models which will be running on smaller GPUs or even CPUs. there will be like some deep reasoning models, right? Let's say you want to like find like cancer detection patterns or something like which is like super hard to do, requires a ton of compute, right? But if you want to learn like what is the color of sky, right? You don't need like that big of a model. Like you're fine with a CPU based like small model, right? So it's just the complexity of task, right? And these are all part of an integrated pipeline. So it's just the complexity of tasks that will define what kind of compute you should throw at it. Whereas I think in the today's world, it's still very like give the biggest GPU, the biggest hit
Yeah,
everything with
but
a tank rather than a
that's not
cycle. Yeah,
always the right answer. Yeah.
yeah, that's, no,
So so let's talk a little bit about right now. When I ask ChatGPT a question, I'm getting a response back in seconds.
yep.
Do you see any need for inference in real time, where it's not a human asking the question anymore? Now it's a machine asking the question, or maybe I'm trying to do threat analysis. Um, I want that really quick. I don't want seconds. I want microseconds so I can shut down a network port, right? Or something like that. Do you feel like the technology is moving in the direction where we can get to more real time inference, especially out at the edge? Because I think that's where the real world meets compute, meaning I've got sensors that are watching things or smelling things or fire detection, all these sorts of things.
Yeah,
How
I
do we
mean,
move into that space? Is that space going to
yeah,
grow too?
yeah, I think the edge AI is, I think, the most underlooked like sector right now, especially because like of the network latency and the sheer volume of data, right? So let's say you have like in future 10 million plus cars driving around, right? So if there's a central server trying to compute the road for like the next navigation for each one of them, it's not going to work, right? We
It's not
need
going to work.
devices on
Yeah.
edge, yeah. So I think with Jetson, like I think this year, like they launched like Jetson Nano Super, which has now got to like 67 TOPS, which is like a lot of like teraflops to operate on the edge. So I think edge-based computing is definitely needed. So it could you can think about like smart devices or let's say even self-driving cars or robots that have like 80% of the computation that they have done locally. Let's say if a car comes in, right? I don't have the time to send my response to Chat GPT and like expect it to like probably give me the answer, right? The car would have run over me past that. So those are things that we definitely need on edge. And the more we can do on edge, the more we can have like smarter systems which can be like scalably deployed, right? So we see these smaller GPUs, especially with Jetson coming up, and now they're also building this Thor, which is right now not like in production, but
Well,
I think they're
what about specialized chips? I mean, GPUs are graphics processors. Let's be
yep,
serious about it,
yep,
right?
yep, yep,
They're not neuromorphic processors. Do you see the
yep.
rise of neuromorphic processing, or custom made ASICs that handle object detection, or do you see a rise in that happening? Because power is a problem, and GPUs are power hogs. So do you see those rising, or are they just too complex to program? I mean, what are the downsides there?
Yeah, no, I mean, definitely for I think specialized tasks, right? I think wherever there's a tokens per second is the only thing that like you need for scale. And like I think talking about like specialized hardware, right? I think Google just launched their TPU, which has like 48 exaflops per pod, which is like much more than I think NVIDIA. So again, I think there will be definitely like task specific chips which we see built, especially for I think things like vision and other things where you don't need like a general purpose GPU, and those will be the ones which will just like be super efficient. So there, what we care about is how many tokens can you output per second. What is the best way to do that? So I think definitely there's a big market for like specialized tasks when it comes to like these hardwares which are like ASICs or like specialized software for like hardware for doing specific tasks. So we see definitely that is also like a very like people just try to like shoot everything with a single bullet now, which is again like not the future which we see. So there will be
Well, we
definitely
we saw that with Bitcoin, right? everyone
Yep.
was buying GPUs to harvest Bitcoin, and then they came out with
Basic.
Bitcoin ASICs,
Yeah.
and the GPU market plummeted like
Yep.
overnight.
Overnight.
And
Yeah.
then AI came in, and now
To save
GPUs
them.
are
Yeah.
to save them. But so I mean that could happen, right? I mean, it's an
Yep.
interesting. This whole thing is a very interesting marketplace. So, hey, Nilesh, if people want to find out more about what you guys do,
Yep.
um, what how do they interact with you guys, and then how do they find out more information?
Yeah, no, I think when they want to like think about AI deployment, right? Especially like for medium-sized small models or like models which are of different capabilities, right? So we help companies like Clean Lab, Usher deploy these different pipelines, right? So these pipelines could be at the guardrails. These pipelines could be at the like where you have a graph of models and you want to deploy multiple models to us. So these are all the kind of problems we help them like deploy machine learning models for and scale. Our company, like InfraLess, you can just visit our website, infraless.com. There's a pretty good self-starter page where you can sign up and literally deploy like DeepSeek or like Llama 4 kind of models, like with just one click. But then again, if there are more use cases where you need, let's say, private endpoints, you need data security, you need like things to go offline, we help those things. And then best way reach out to us is like via the email. So I'm at Nilesh at the rate of infraless.com. We can reach out to us. We are happy to help you deploy AI in the most efficient manner. And one of the value props that we do is we don't want you to like keep the GPUs always on. So you use them, you only pay for tokens what you use, and then it shuts down. And you can
Nice.
do as custom models as you need. So that's what our value prop is.
That's awesome. Nilesh, thanks for coming on the show. And obviously, you're out there trying to create efficiency and save money for these people using these LLMs. So I think this is awesome. So thanks again for coming on the show.
Yep. Thanks, Darren, for having me.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.